Hello, this is Looking Forward for Physics 201 for Friday, the 3rd of March, 2017. As you get ready for class on Friday, I'd like you to take a look at sections 4.1, 4.5, 4.8, and 6.6 of your book. 4.1, 5, and 8 have to deal with basic differentiation things you've seen before. 6.6 deals with something called the gradient and the directional derivative, which you've probably seen also. After taking a glance at those and look through, I'd like you to think about the following things. When we define our derivative, let's say df dx, and we define it to be the change in f, or f as I change x, divided by the change in x, and I take that limit as delta x goes to 0. What does that mean? Okay, we know it's the slope. That part is not what I'm talking about. What we're really asking here is, what really is going on here? What are we calculating? And more importantly, when we do that, as we're making that sort of calculation, f of x plus delta x minus f of x all over delta x, does this say anything about other variables? Does it say anything about whether or not this function f is a function of y, or a function of z, or a function of time? And based upon that silence, what can we infer about our meaning of this concept of a derivative? Second of all, if I take and I consider the derivative, now let's consider a function g of several variables, let's say x, y, and z. Is it possible to talk about not just the slope of a one-dimensional function, but the slope of a three-dimensional function? And if we did consider such a slope, would there be a direction to it? Or better put, what would be the direction of that? And then finally, if I knew the vector slope, how could I get the slope in a given direction? Let's say you had. We'll talk about those things and more when we get together on Friday. See you then.